And this is a conjugate pair. It needs the same terms, the opposite sign in the middle. So now you have your three factors. Then you have your three roots. So we'll make your factors. This guy, make into a factor. Set it equal to 0. This is part of it, right here. Make sure you give me f of x equals or y equals. I need an equation. Now, to do the other part, how am I going to get that quadratic out of there? Sum and product. Good. Sum of the roots and product of the roots. Again, put it in your calculator. Let your calculator do this if you struggle. Put it like this, with parentheses plus, and hit enter. It's going to add the 3's, 6. Remember, we let a equal 1. So therefore, what's b? Negative 6. Now, in your calculator, second enter, change this to a multiply. These are conjugate pairs, so these are your perfect squares. Your middle terms knocking themselves out there. So 6, 3 times 3 is 9, and your last one is 2. Or put it in your calc, let your calculator do it. Therefore, what's c? 7. So here's our quadratic. X squared minus 6x plus 7. That's what gave us this piece right here. And so now we go here and we say, I'm going to just move it down. Okay, and just leave it in factored form. I'm okay with the factored form part, because it's easiest just for us to recognize where those roots are coming from, and we're good with that. Good? Yes? Okay. It's very hard to do without this. You can do the same way you do that, subtract it, and then when you FOIL it, it is a little bit longer to FOIL, but it does work itself out in the end. But it's so much easier with your sum and your product rules. Okay. Now, these guys. We've been doing the sketch and describe. And we had everything there. And when you found your exact zeros, you factored. The only difference that we've done between that last describing and this describing is that we can't factor this. So we throw in the synthetic division to get all our zeros out of this. Everything else stays the same. You still need your x-intercept, your y-intercept, your domain, your range, your equilibrium, your inflection. Everything else is the same. It's just the algebraic way that we're going to find your roots. And because I don't give you anything, you have to graph it. You have to find at least one. How many do you expect this to have? 3. If you could see all 3 roots, that's fine. But I need to see it algebraically. So technically, you can synthetically divide till you hit that last root. That's fine for me. Or you could divide till you get to a quadratic and then factor it. When in the case of an irrational, you're going to end up using your quadratic formula. So when you graph this, you find the sketch, and it looks like this. Something like this. Right? Well, actually, one sec. I know it dips down here. It doesn't exactly cross at the 0, 0, but I know it dips down here. Start and find at least one root. So how many roots can you actually see when you look in your calculator on your table? 1. And that was what? 1. When x is 1. So start with 1. Pull out all your coefficients. Bring this down. Is everybody okay with the synthetic division part? It's getting to be kind of routine. The tricky ones are the double ones. If you have to divide by a quadratic, that's the one with it's a double one. But the rest of them should work kind of nicely. So bring these down. Remember, if this doesn't come out to 0 and you found that factor, then something went wrong, such as a biphase. I can't talk and write. Oops. I'll do this either, apparently. I can't talk and write at the same time. Was this a 4? 5. Bring this up, add this down, multiply, come across. If this is not 0, then I did something wrong. I go back and I look, maybe I forgot one of my signs. Maybe I forgot a space holder. The space holders always get you in trouble, especially at the end. Now, it's the easiest way. You had x to the 3. You took 1 0 away. So now you're left with x to the 2. Just say it real simple. X squared plus 5x plus 1. This is my other factor. Now, can I factor this? No. So I got to use the quadratic. Make sure you know the quadratic formula. Or you can complete the square. Usually for me, if this is a fraction, if this is going to end up as a fraction, I tell kids to use the quadratic because I know you panic over the fractions, then you got to square your fraction, you got to add it to the 1. So in this case, it's probably a little easier, or if you have to factor anything out, it's probably easier just to use the quadratic and get it done with. And you should come out, and these are your exact values. So these are the ones we need. Even though you can check them and look at them, you need to find them exactly. Reduce any radicals that you can reduce. And it comes out this way. Now 21 is not reducible. So your roots are 1 and negative 5 plus or minus radical 25 over radical 21 over 2. Now those are your x-intercepts. Don't forget your y-intercept. Your y-intercept is the easier one. Your y-intercept says plug in the x of zeros. When are they sleeping?
1 minute after 7:30.
Really?
Yes, 7:31.
Ah. Okay. So you're going to plug a 0 in. This one's the easier one. 0 plus 0 minus 0 minus 1. Y is equal to negative 1. Don't forget to do this one. It's the easier one, but because we go through all this work, we forget it. Okay. Max and mins. Can everybody find and label their max and mins? Are these absolutes or relatives? Relatives, because this is infinity here, infinity there. So we'll label A relative max, B a relative min. 3 decimal places. I want 3 decimal places on this guy. No one decimal place. I won't take them anymore, guys. I give you a break, but I'm not going to take them anymore. And your relative min. Okay. From here, you could do your increasing, decreasing. All right, increasing. Increasing, you're looking at the value of y as it's going up and down like a roller coaster, but you're measuring through the x's. You're telling me y is increasing here, but what does that mean to me? It means nothing. It means y is increasing when x goes from negative infinity to this point, that my y value is increasing. So you've got to give me the x, negative infinity to that point. Then y is decreasing. Write them both at the same time. Then y is decreasing from that x point to the bottom x point. And then it increases. Your increase and decrease should cover all of your domain. What is the domain and the range for this guy? All real numbers. The cubings are nice because they're all real numbers. Be careful when you have a range and you have a hard bracket. Make sure you use your hard brackets for those. So we had 3 roots, 2 terms, 1 inflection point. Your inflection point is your concave down, your concave up. There's your inflection point, halfway through. To get the halfway is your midpoint. Take the midpoint of the x's. So your inflection says this x value, right there, negative 3.097 plus 0.431 and divided by 2. Get your inflection point. Okay? A point has an x and a y. Go back to your calculator, plug in that value of x, and get me the y. You only need that y just because we call this an inflection point. Okay? And from here, you can do your concave up and concave down. Remember, it's like that total motion that you're going through. Even though you're increasing here, you're caving down. So from negative infinity to that x value, you're caving down. From that x value to infinity, you're turning up. So you're caving up. Okay? How did that work? You didn't get that inflection point? You got 1.333?
Yeah.
Everybody? Okay. Mine's probably wrong. Negative 1.333. And what y did you get? What's your y?
9.071.
Okay. So I'll just... 0.07. Thank you. Okay. Went wrong on mine. Oh, here's mine. This one's for good start. Okay. Got it all kind of scribbled on here. All right. So are we okay with this? Are there any other pieces we're missing? Concaves, absolutes, decreasing? Nope. Okay. Everybody okay with this? All we changed was this synthetic division part. That's it. Because now you couldn't factor, so you pulled out your roots through synthetic division. All right. Let's hit the next one. God bless you. All right. I'm going to go to the last one to do this first, just in case we don't have enough time, because that was a cubing one. So just in case we don't have enough time, I want to hit the 1 raised to the 4th. Now, how many zeros should you find? 4. How many turns? How many inflections? 2. Okay. So when you graph this, you notice this was a W. It went like this. I'm sorry I'm keeping you awake. All right. Label these guys. How many roots? We see 3. But you told me there would be 4. One's a double. Which one's the double? The 2 right here. Do you see it bounce off and not go through? These guys right here, you can't see them on your calculator. Because what kind of roots? Shh, boys. Okay, what kind of roots are they if I can't see them in my calculator? Irrational. They could possibly be rational, be a fraction, but chances are they might be irrational. This guy is my double. So when you do this, take it out twice. So let's do it the first time. Make sure you have all. 4, 3, 2, 1, 0. If you don't count down and you go through the whole thing, then you got to do it again. So bring this down. 1 times 2 is 2. Bring it down. Negative 12. Bring it down. 14. Bring it down. 4. If this is not 0, then something went wrong. Now, because I started with a 4 and I took 1 away, very simple, I'm down to an x3. Can I factor this guy in a cube? No. I want to take out another one. I got to take out the double root again. So do it again. And again, your remainder should be 0. You're probably going to end up with something that's not factorable. And there's my 0. So I'm left with a quadratic, and my quadratic is a factor, and I have to get the roots out of that. So since I can't factor it, I have to use the quadratic formula again. Boy, this is not a bad one. This is a nice one to complete the square. Remember, complete the square? This one's even nicer to complete the square. I'm going to move it over here. Okay, what's half of -4? What's 2 squared? 4, 4. Add 5. Then take your square root. Don't forget you get plus or minus. And then add your 2. That's a nice one to complete your square. If it was as simple as that, I would do that rather than the quadratic. The quadratic has a lot going on. You've got 2 negatives in there. You've got a negative for your B. You have a negative for your C. So, I mean, that's a nice one to do for complete the square. Don't forget your y-intercept. Say, let x equal 0. So therefore, y is equal to -4. I'm okay with you doing this, as long as you tell me x is 0. Rather than write out all the zeros, when x is 0, it's all gone except for that -4. Okay, are these relatives or absolutes? Absolute mins. They are absolutely the lowest point, and they are the same y value. It's not symmetric through the y-axis, but it is symmetric through this turning point right here. So these guys are absolute mins. So point A, such a mess here. 3 decimals. Make sure I get 3 decimals. And B is going to have the same y value. Did it round to 65? Yours too? Okay. Now, what's this called right here? C. Relative max. Without even going through your calculator, do you know what your relative max is? 20, isn't it your root? The problem when you go to your calculator is I think this one makes the 200.00 something and either the negative, but you know that's 20. You did that root. You took that 0 out. So this has to be 20. So there's your relative max. Okay, let's do increasing, decreasing. God bless you. The y value is decreasing. From where? From my x is -infinity to that A point. Just keep going with it and fill them in. Then my y is increasing from where? From this x value to the cx value. Okay? Now, I turned and I decreased. My y value is decreasing from here, this x value, to the bx value. Just do them both at the same time so you don't have to keep switching gears, and make it go smooth. From 2 to the b. And then the last one, it's going to increase from b to infinity. The x value, not the y values. It is your y that's increasing, decreasing, and you see your y increasing, decreasing, but you have to read it through your x's. Your y increases while x is moving left to right. Give me the values of your x's. Okay, inflection points. I've got a concave up, a concave down, a concave up. You've got 2 inflection points. So take your average of your A, which is 4.419 plus 2 divided by 2. And do this side. Your inflection points, you got to have 4 roots, 3 terms, 2 inflections. And you've got to give them to me separate because they are 2 separate points. So does anybody have, oh, here it is. 2.766, is this it? Oh, that's D. And D is they both have to have the same Y because they're symmetric about the 2. So the X's won't be the same, but the Y's will be the same. Okay, so now do your concavities. Follow your Y's as it's caving up. Your Y is caving up. That turn that you do is an upturn over here. So you're concaving up from negative infinity to that 1.277. Then you're concaving down between these 2 points. Usually your down is between the 2 points, where if you're curving up on the other side, it's between. So one of them has to have an in between the both points there somewhere. So between 1.277 and 2.766. Then you're concaving back up again. Remember, everything goes off those X values, not the Y's. Everything has 3 decimals, everything goes off the X's. Now, let's hit your domain and range. What's your domain for this guy? All real numbers. Is your range all real numbers? No. Your range starts at this number, whatever this Y is, and goes up. So my range, hard bracket, whatever this Y is for A and B, there's where my range goes, to infinity. Whoops. If it went the other way, I would start with this, and it would go down, but I would have to write negative infinity to that point. So watch which way you set those up. Because a couple of you set on the other one, they were backwards. So you had the concept, but you just kind of set it backwards. Make your hand go from here to infinity. The other one's going from negative infinity, stopping here. So it's got to follow your number line left to right. Okay. And that was that one. Questions? All right, let's hit this other one real fast. As a matter of fact, let's bring up the answer sheet and we can just look at the answer sheet. Hang on, guys. There's my 1.33. I just took it off the wrong problem. Okay, this is the one that I didn't do. I did this one. Okay, this is number 4, guys. Just so that you could walk through it. Again, you're going to have 3 zeros. The problem is we can only find 1. And then when we reach this point, this is not factorable because watch. 8 times C says, do you have factors of 6 that add up to 6? No. If you use your complete the square, don't forget to factor out the 6. And that's perfectly fine to do that. You get a little fraction. Yeah, so sometimes it's easier just to flip to the quadratic. You can put this piece right here without the radical sign in your calculator and just bring the rest of it back down. Well, then you got to reduce it. I reduced my thing. Just make sure you reduce. All the way to the end. Make sure you reduce. Don't forget your y-intercept. You have a relative max, a relative min. There's no absolutes here. And this one was symmetrical. So you increasing, decreasing, 1 inflection. This is nice. Questions on this one? No? All right. Monday is a test. gonna look